A general solution of a trig equation, part one. We're going to have a couple different videos on this. We're going to start with a cosine bt equals c, and we're going to assume a is greater than 0. You can always make it as such. We can produce a general solution if it turns out if c is greater than 0. We'll use these two formulas, and if c is less than 0, we'll use these two formulas. Couple things to note. Inside this inverse cosine, we use absolute value just to make sure that these quantities are always positive. And the reason is inverse cosine of c over a is really a reference angle, and if c is positive, we have a quadrant 1, quadrant 4 solution. And that's where we have, this would be first quadrant, and then we can add any multiple of 2 pi, divide by b because of this here. And fourth quadrant solution, that's where 2 pi minus comes from, minus the reference angle, plus any multiple of 2 pi, divide everything by b because of this. C is less than 0, the cosine is negative in quadrant 2 and quadrant 3, that's why we have pi minus and pi plus. Pi minus takes us back to quadrant 2, pi plus takes us into quadrant 3. There are obviously certain commonalities here. We always have 2 pi over b times n at the end. That's just standard. Everything's divided by b, and of course you can just remember reference angle first quadrant, 2 pi minus fourth quadrant, pi minus second quadrant, pi plus third quadrant. So we're going to look at one example here. Let's suppose we want to find the general solution of 3 cosine 4t equals negative 1. A is 3, b is 4, c is negative 1. C equals, which is less than 0. So we're going to use this one right here. C is less than 0. We're going to have a quadrant 2, quadrant 3 solution. And so let me erase that. And so we have t equals, we're right here, pi divided by b, which is 4. And then we have minus inverse cosine c over a, absolute value negative 1/3, divided by 4, plus 2 pi over 4n. And then we also have t equals pi over b, again b was 4, pi over 4 plus inverse cosine negative 1/3 absolute value divided by 4 plus 2 pi over 4n. You notice the only difference here is minus and plus right here. So you can figure this out at 0.7 something, figure this out, plug it in. Make sure you're in radians. If your calculator is in the degree mode, you will not get the correct answer. Here are the two answers, quite simply put. Find inverse cosine of 1/3. You don't need to put the absolute value in, just strip the sign away. Inverse cosine of 1/3 divided by 4, and subtract that from pi over 4. If you're in pre-calculus, you should be able to evaluate that. This is really pi over 2, 1.5708. And do this plus. Here are the two answers, 0.4777, 1.0931. That's greater than that because we have a plus. And that's the order of things. Find that coefficient, you get a number. Find that coefficient, you get a number. This multiple of pi. And there's a solution. T plus this number plus 1.5708n. Now what does this mean? We'll need a calculator for this. Well, you can erase this. And suppose we want the first 4 solutions. Well, we're going to let n equal 0 first of all. So we're going to plug 0 in for n, and we get, you can call this T1 equals 0.4777 plus 1.5708 times 0. And guess what? That's 0.4777. That just zeroes out. T2, you can plug 0 in here. 1.0931 plus 1.5708 times 0, and that's 1.0931. Okay, let me get a new marker here. There's T1 and T2. Let me list those numbers over here. 0.4777, and you can see the time progression, 1.0931. Now let's erase this. We'll find the next t values. We are going to let n equals 1, and we're going to plug 1 in here and 1 in here. And you can calculate what we'll call a T3, 0.4777 plus 1.5708 times 1. And we can calculate that as and we get 2.0485. Let me list that over here. 2.0485. So we have a half a second, 1 second, 2 seconds, roughly. And then we have T4, we want to put n equals 1 right in here, 1.0931 plus 1.5708 times 1, and we can calculate that, 1.0931 plus 0.5708 equals, well, then we try that again. 1.0931 plus 0.5708. And I got 2.5639. So if you do that minus that, you should get the same as that minus that. So if we wanted the first 6 solutions, guess what? We would just let n equal 2, and that would give us 2 more solutions. N equals 3 would give us 2 more solutions. Of course, we have an infinite number of solutions to this trig equation. So that's the end of part 1. We'll be back with part 2 shortly.